This is a video on converting using dimensional analysis. We primarily use the metric system in science, and the metric system is made up of what we call base units. And our base units usually are meters, liters, and grams. And these base units, you can tack a prefix onto any of them. So for example, if I'm going to look at the base unit of a meter, I can have a kilometer or a centimeter. And the kilometer, for example, is 1,000 meters, 10 to the third. And then something maybe not as familiar is a nanometer, which is a very small unit. And we'll use it also later on this year to talk about wavelengths and measuring wavelengths in nanometers. And so that's 1/billionth of a meter. So you got the TH there, meaning, right, it's a billionth, a lot smaller. So 1 times 10 to the negative 9 meters. And if you remember in class, you had received a reference sheet to memorize your metric conversions. And then looking here at this reference sheet, something a little different. I'll zoom in so you can see. In this sheet here, you get a layout of all the different prefixes. And so here's where your base unit would be inserted. So if we were to say, again, something like a meter, then 1 meter, right, is equal to a deci. That would be a tenth of a meter. Versus if you look up here at the bigger units, you've got the mega with a capital M, 10 to the 6th, kilo, 10 to the 3rd. And then careful, because the upper and the lower case letters do actually matter. They denote which prefix you're using. So look at the lowercase m for milli and the uppercase for mega. Pico is another unit you'll see us use as well. That's 10 to the negative 12. So you've got really big and very small prefixes. Okay, so now using our conversions, let's begin and learn how to use something called dimensional analysis. Dimensional analysis will be the only way that you will be given full credit on your conversions. Using any other method is great maybe for checking, but not for our class for full credit. So please make sure that you learn this system. So here we have this first example. How many millimeters are there in 20 centimeters? And let's also remember sig fig. So 20 centimeters with a decimal at the end means that that trailing zero is significant. So I have 2 significant digits in my measurement, or this ruler right here. That was my certain place, and this is my estimate. So I'm going to start off with my given value, so 20 centimeters. Don't forget the decimal. Make sure to retain your sig figs all throughout. Also remember that every number is a measurement, so make sure there's a unit on there. So I start here with my given number, and I want to convert my centimeters into millimeters. And I notice that my centimeters is a prefix and a milli is a prefix. And so in order to go from one prefix to another, you want to hit the base unit, and the base unit is the meter. I know that there are 100 centimeters in 1 meter. So notice I went straight to the base. My centimeters on top cancel out with my centimeters on bottom. Now I'm not going to stop and solve here. That's a little bit too early to do that. If I do that, I could maybe end up with a little bit more error or rounding issues or sig fig issues. So notice that I'm going to keep going in one long setup with 2 conversion factors side by side. Please note that this is important and that you'll be expected to do this, and will receive points off for setting up separate setups continuously. That wastes time and could lead to more error. So then whatever unit I have on top here, I'm going to put down here because it needs to cancel out. And whatever I want to go to needs to be up on top. So how many millimeters? So now my next step is, how many millimeters are in a meter? Remember we said this is a good time to check your reference sheet and notice that there's 1,000 millimeters in 1 meter. Milli's prefix is 1,000. So the millimeter does not cancel out. So now I'm going to get my calculator, and this is a great time for you to also pause the video and get your calculator as well. And I'm going to show you how to put this in your calculator. So here's one version of the calculator that you can have for our class. So I'm going to start off with our given here and put 20. Remember, in the calculator, 20 and 20 point are the same thing. So 20, and then that's times 1 divided by 100 times 1,000 divided by 1. So notice this is a fraction, so top divided by the bottom. Or you can just say 20 divided by 100 times 1,000. So 20 divided by 100 times 1,000. And so I get 200 as my final number, but remember, I still need to retain my sig figs, and my sig figs in my given is where I will look. So my measurement is this 20 centimeters. These conversion factors are not my measurements. Instead, what we say about the sig figs in these conversion factors is that we say that they're infinite. So I'm going to draw these little infinite signs, infinite, infinite, 2 sig figs. So it's not just 1 meter equals 100. This is a standard. So it's probably something like 1.00000 infinite zeros divided by 100.00000 infinite zeros. So it's a very good measurement, right, as a standard. So I will never look at my conversion factors for my significant figures. Instead, I'll always go back to my measurement. So 2 sig figs, so my answer needs 2 sig figs. Remember, it's impossible to put 200 into 2 sig figs without doing scientific notation. So I'll put this into 1, 2 scientific notation by moving the decimal place over. And now I have 2 sig figs, but retaining the magnitude of the number. It's a number in the hundreds place. So 1, 2, 10 to the second millimeters, and the unit goes at the back end. So now I've kept the magnitude, so my place values are there. I have my correct sig figs, and my unit is at the end. So that is my final answer. Again, notice one long setup. Please don't split it up into 2 with 2 equal signs. You will get points taken off. Okay, let's look at a slightly different version. I'm asked about units that are cubed. You could be asked about units that are cubed, squared. It works the same way. So I'm going to again start with my given. So I've got that 380 with a decimal centimeters cubed. And I want to go to how many meters? So I'm actually going from a prefix to the base. So this one's a bit easier. And I know, like we saw in the last example, there's 100 centimeters in 1 meter. But they asked how many meters cubed are there in centimeters cubed. So since this is a cubed unit and I want to get to a cubed unit, I'm going to just actually put the entire conversion factor into parentheses and I'm going to cube it. That way this ends up being cubed and this ends up being cubed. So therefore this and this end up crossing out and my final unit is going to be cubed, which is what I wanted to find. So now to put this in my calculator, I have to be careful to cube this part. So I'm going to start by putting in my given. So that's 380. And that number's not cubed. Remember, the unit's cubed. And I'm going to times it by 1 divided by 100 cubed. Or, since 100 is in the denominator, I can just divide by 100 cubed. So I'm going to hit 380 divided by 100 cubed. So now you have to find the cubed feature on your calculator. If you're using this one right here, you're going to do 100 and then you're just going to use the caret button and you're going to raise it to the third. So again, remember that's being divided and hit enter. So I get 0.00, so I get a lot of zeros. Remember, scientific notation is used for instances like this. So I'm going to move my decimal place over 1, 2, 3, 4 places. So let's write that down. So that's 3.8 times 10 to the negative 4th meters cubed. So just kind of shimmy my answer down here. But notice I have 3 sig figs here. So in order to make this match, I just have to add a 0. Remember, your calculator doesn't do that for you. Your calculator doesn't do sig figs. You have to be the one to know to do it. And again, I move my decimal place behind the first non-zero digit. So that's 1, 2, 3, 4. Negative 4, small numbers, negative exponents. So that's my final answer. If you're not using this calculator and you're using the CAS, you might have an x raised to a certain number. So you just want to make sure you find your feature on how to cube and square. So this next problem, I want to convert 500 with a decimal point nanometers to meters. So I've got a prefix and I'm going to be going to a base unit. Careful with my sig figs. Also be careful when you start to do work. You want to make sure that your work still retains the same good sig figs. So don't get sloppy and forget your decimal point when needed. Remember, in your dimensional analysis, you want to use the abbreviation for nanometers. Please don't write the full unit out, and that's NM lowercase. And we're going to use our same dimensional analysis setup. Remember, it looks like a fraction. Whatever unit's on the top needs to go on the bottom to cancel out. And then whatever I'm going to needs to be on top. So look here, cancel, cancel. And my 1 meter has 1 times 10 to the 9th nanometers in it. There's a lot of nanometers in a meter. Remember, nanometer is a small unit, and there's a lot of them in a meter. So at this point right here, let's just make sure we remember that the conversion factor has infinite sig figs, and my measurement is this up here in the front. Trailing zeros are significant so long as there's a decimal anywhere in the number, so 1, 2, 3 sig figs. So my final answer, once I calculate it, will have 3 sig figs. That's a 3. And the final unit will be meters. So before I plug it in my calculator, I'd like to actually teach you a better way to put scientific notation into your calculator. So if I want to put something like 1 times 10 to the negative 9th scientific notation into my calculator, I'm going to use something called an EE button. So on this calculator right here, the EE button is right above the x minus 1. So in order to bring that up, I would have to hit the second button and then the x minus 1 to get the EE right there. If you're using a CAS or TI Inspire, here's my little hand-drawn one. So here's my CAS or TI Inspire. Your button is down in the lower left-hand corner, and there's 2 capital E's. Careful not to confuse it with the lowercase e. It's 2 capital E's. So if I'm going to put scientific notation in, then I want to make sure that I don't accidentally press extra things. So let's just really quickly remind ourselves. In scientific notation, this does not mean 1 is multiplied by 10. Instead, what it means is this is my measurement, and it's a base of 10 system. And then this tells me my magnitude, how big or small my number is. So my places. So I can see this number is very small. So I don't want to press times 10 in my calculator. That's what I do not want to do, right? I'm not going to hit multiply and 10 ever in my calculator when doing scientific notation. So let's just clear that out. So what I do want is I want to use the scientific notation button, which is this. So to put this in my calculator, I literally would just do 1. So you could see I brought the 1 in. And then second, x minus 1 for that EE button. Now I know I said EE, and that is correct if you see where my finger is, but on the screen it'll just bring up 1E. So then now the next thing I'm going to do is I'm going to put the exponent in. So you'll see me write negative 9. So here is negative 9. And that's it. And that's how you put in scientific notation. Notice there's no times 10. Now let's go ahead and practice with this problem here. So we're going to take our calculator and we're going to put in 500. Remember, 500 with a decimal and 500 without. In a calculator is the same thing. And remember, we can do times 1 over our scientific notation, top divided by the bottom, or we could just say 500 divided by our scientific notation. So I'm going to hit 500 divided by, and then 1. And then remember, for this calculator, it's the second button, and then the x minus 1 brings the e up. So e, and then just the exponent 9. Remember, it looks like this with 1 e, even though your button has 2 e's here. And again, the CAS calculator has it in a slightly different location. Please make sure that you're following along and you have your calculator. So now that I'm done, I hit the equal sign and I notice I've got a very small number. This is the point of scientific notation, is that I want to put this number into scientific notation. And I don't really need to put it into scientific notation for sig fig reasons, but rather that's just what you do for numbers that are very small. So I notice if I move my decimal place over, I got 1, 2, 3, 4, 5, 6, 7. So I'm going to move it over 7 places. So I've got 5 Now again, looking at the calculator, you might say, where are the rest of the sig figs? Remember, your calculator doesn't do the sig figs for you. You have to add the extra zeros at the end there. So 3 sig figs would be 5.00 times 10 raised to the 7th. It's a negative 7th there. Remember, a small number would be a negative exponent. So 3 sig figs, 3 sig figs. Next, we're going to learn how to convert using fractions. In other words, we're going to actually start with a given that's in a fraction. So you have 2.00 meters per second, and you want centimeters per minute, let's say. So we call this converting fraction units. The way I'm going to do this is like I've been doing using dimensional analysis, and that is I'm going to set up what looks like kind of this side slash into a top and bottom fraction numerator and denominator. So please don't keep it as a side slash. Instead, look how I've transferred it like this for dimensional analysis. Remember, formatting is the most important thing right now. Next, I'm going to multiply it by my conversion that I've used a few times already, and that's my meters per centimeter. So I have 100 centimeters and 1 meter. So I've already done the first part, and that's converting my meters into centimeters. If you remember, this was what I was asked. So how many centimeters per minute do I have? So my centimeters is great. It has not canceled out. It's still on the top. And my last step is my seconds over minutes. So how did I know what to put on top and what to put on the bottom? First things first, I started with the meter, and I said I need to cancel that out, so I put that down here. And I knew that a meter can go to a centimeter, so I put that up here. So I handled the numerator first. Next, I'm now going to handle the denominator. In this instance, my unit S is in the bottom, and I need it to cancel out. So now it's up here at the top. Remember, in math, we learn units on the top and the bottom can cancel out. And so I know that there's 60 seconds and 1 minute. And then I look and I say that I have a centimeter on top and a minute on the bottom. And I again remember that that was what was asked of me. Centimeters on top, minutes on the bottom. And so I've correctly set this up. So how does this go in my calculator? Remember, these are all just fractions, right? So this is this number over a denominator times this over a denominator times this over a denominator. So technically, I could say 2 divided by 1 times 100 divided by 1 times 60 divided by 1, or 2 times 100 times 60. So I'm going to go ahead and put that in. 2 times 100 times 60. And I get 12,000. Remember, again, conversion factors are considered infinite. That 1 is considered infinite. And that 2.00 meters is my actual measurement, not that 1 second. So I have 3 sig figs. So I have 12,000 centimeters per second. And I notice that that has the wrong number of sig figs. That only has 2. So I have to put it in scientific notation. So 1, 2, 3, 4. So that's 1.20 times 10 to the 4th centimeters per second. And that's my answer. Okay. Next, you can actually use dimensional analysis with density. And the way to do that is you need to know a specific substance's density. Every substance has its own unique density. So let's take a look here at this example. So first of all, it says if we know a substance's density, we can use it as a conversion factor. And here is water's density. It is 1 gram over 1 milliliter. Remember, water's density is not really in 1 sig fig. Again, so we're going to look at these as infinite sig figs. So now here's my problem. How many milliliters of water is 70 grams of water? And I can use that as my conversion factor. So I'm going to start off here with 70 grams of water. And I'll write H2O times. And so I notice that the only way I can go from a mass unit to a volume unit is density. So I'm going to flip this conversion to properly go into here. And if I've got grams on top, then I want grams on bottom. So I'm going to flip it around and put the mass on the bottom and the 1 milliliter on top. And I know what you're saying, this is easy, I could do this in my head, but remember, we're trying to reflect that we understand how to do something, right? And nobody can read your mind. So this shows that you understand taking your mass and multiplying it by density as a conversion factor can get you to a volume. So that cancels out with this. Also remember, not every substance's density is 1. Every substance has its unique density. So now I have 70 milliliters, but let's just double check the sig figs. You don't want to copy down an answer or a given with a wrong number. So let's just make sure. So we just have 70, which means that's 1 sig fig, infinite, infinite, and then my answer needs to have 1 sig fig, which it does. And that's it. There's my answer. Lastly, we're going to talk about temperature. In the metric system, we like to use 2 temperature systems, and that's Celsius and Kelvin. We're familiar with Celsius. Kelvin might be something a little new for us. We're not going to be using what we're familiar with in America, and that's Fahrenheit. So our Celsius assigns 0 as freezing point, and pure water boils at 100 degrees Celsius. And so room temperature in Celsius is about 20 degrees, and body temperature is about 37 degrees. In the Kelvin, they assign 0 as the lowest temperature that can ever be reached. So there's no negatives, whereas in Celsius, you can have negatives. So the lowest temperature in the Kelvin scale is considered absolute 0. And this happens at what they call negative 273 degrees Celsius. Thus, 0 degrees Celsius is 273 K. So to convert from your degrees Celsius to Kelvin, all you have to do is add 273. So then looking at this picture of 3 different thermometers seen here, these thermometers are the Kelvin, the Celsius, and the Fahrenheit compared side by side. And the nice thing about this is they show you what each one, let's zoom in a little bit, right? What each one looks like at the main point. So like water boiling is at 373, that's at 100 for Celsius, and that's at 212 for Fahrenheit. Remember, we're not so concerned about Fahrenheit, but at least it's familiar. Same thing with human body temperature. You're probably very familiar with your body temperature in Fahrenheit, but here's what it looks like on the other scales. And then the points we're talking about, which is where water freezes. We know water freezes at 0 on the Celsius scale, and it's 273 on the Kelvin scale. And then lastly, that absolute value you could see down below here, right? And so you can see why we use 273 as a conversion factor, since 0K is the lowest on Kelvin, and that's negative 273 on Celsius. So now if we want to convert degrees Celsius to Kelvin or Kelvin to degrees Celsius, all we have to do is use that conversion factor. So let's try one right now. So let's say something like we have 10 degrees Celsius. How many Kelvin is that? All we have to do is add 273 to that, right? And that will give us Kelvin. So in the end, we end up with 283K. And if you remember, we're adding. So for sig fig rules, you want to go to your least amount of places. So I've got no places after the decimal, so no places after the decimal. Be careful, because if this measurement was 10.0 degrees Celsius, then that meant I had a tens place on my measurement. Also be careful that, as you've noticed, the theme about conversion factors is this 273 is actually infinite. And there's more numbers to it. So it's 273.14, keeps going on and on and on. We generally like to use 273, it's just easier. So please do not look here for sig figs. There are more sig figs in this measurement. So I'm going to look at my original measurement when I'm adding. And I notice in this instance I have a tens place. So my answer is no longer 283, but rather 283.0K. Tens place, tens place.